All right, let's get right into it. We're always hearing about how blockchain is going to change the world, right? But for that to actually happen, it needs to be fast and it needs to be cheap. Today, we're diving deep into one of the biggest engineering puzzles out there, making blockchains faster. This is the quest to solve the scalability problem.
You know, if you've ever actually used crypto, you've probably felt this pain. You hit send on a transaction and then you just wait and wait. Or even worse, you get hit with a fee that costs more than the thing you were trying to buy in the first place. It's a huge barrier keeping this tech from really hitting the mainstream.
So what gives? Why is it so slow? Well, here's the crazy part. That slowness, it isn't a bug. It's actually a feature, a consequence of a really deep design trade-off. You can think of blockchains as having a built-in speed limit, and figuring out how to break it is one of the biggest challenges in the entire space. And that brings us to the absolute heart of the matter. Something the creator of Ethereum, Vitalik Buterin, famously called the blockchain trilemma. Just picture a triangle. At each point, you've got something you absolutely need: scalability, security, and decentralization. The problem, the trilemma, is that you can have any two, but getting all three at the same time is incredibly difficult.
And you can see how it works right here. You want maximum decentralization with thousands of computers all over the world running the network? Great, but getting them all to agree on things takes time, so it's slow. You want maximum security with tons of complex checks to prevent attacks? Awesome, but again, that slows things down. And if you go for pure speed, scalability, you often have to cut corners, maybe centralizing power a bit or creating potential security risks. It's a constant, frustrating balancing act.
To really put this into perspective, just look at Bitcoin, the granddaddy of them all. It can process about 7 transactions per second. 7. Now compare that to something like Visa, which handles thousands of transactions every single second. You just can't run a global financial system on 7. No way.
And here's where the rubber meets the road. When the network gets busy, it becomes a feeding frenzy, a bidding war just to get your transaction noticed. This chart shows it perfectly. Fees can just go through the roof. Suddenly, that $5 coffee you wanted to buy costs you $20 in fees. It makes small, everyday payments totally useless. Now, you might be thinking, okay, that's Bitcoin, it's old tech. Surely the new blockchains have fixed this. Well, not so fast. Let's look at Ethereum, the absolute powerhouse for smart contracts and apps. It does a little better, maybe around 20 transactions per second, but guess what? It runs into the exact same wall.
And just like Bitcoin, when everybody tries to use Ethereum at the same time, say for a hot new NFT drop, the whole network clogs up. You see the same pattern. The transaction fees, which people call gas fees on Ethereum, just explode. Again, that built-in speed limit creates a massive traffic jam that prices out almost everyone.
So clearly, this is a huge problem that needs a real solution if this technology is ever going to live up to its promise. And as the smartest engineers in the space have been tackling this, two major strategies have really come to the forefront.
We call them Layer 1 and Layer 2 solutions. A Layer 1, or L1, solution is all about changing the fundamental rules of the blockchain itself. Think of it like trying to widen the entire highway system. A Layer 2, or L2 solution is different. It's about building on top of the existing blockchain, like adding a super fast express lane that flies right over the regular traffic.
Okay, let's dig into Layer 1 first. This is the most direct way to attack the problem, but man, is it controversial. You're trying to get a massive global community of users, miners, and developers to all agree on changing the fundamental code of the network. It's tricky. Now, to make these kinds of changes, you have to do what's called a fork. A soft fork is like a simple software update. It's backwards compatible, so everyone can still play along. But a hard fork, that's a whole different beast. It's a clean break. The new rules are completely incompatible with the old ones, and it literally splits the blockchain in two, creating a brand new currency. And this is where things can get really heated.
And nothing was more heated than Bitcoin's block size war. Seriously, they call it a war for a reason. On one side, you had people who wanted to make the blocks bigger to fit more transactions and lower fees. On the other side, you had people who argued that bigger blocks would make it too expensive for normal people to run the software, which would threaten the network's decentralization. The fight got so vicious that it ended in a hard fork, creating Bitcoin Cash, while the original Bitcoin went a different route.
So because changing Layer 1 is so difficult and causes so much drama, a whole different school of thought popped up. Layer 2. The core idea is genius in its simplicity. Don't mess with the main road. Instead, just build a faster way to travel on top of it.
One of the coolest Layer 2 ideas is something called a payment channel. The best analogy is a bar tab. You and the bartender don't run your credit card for every single drink, right? That would be insane. You just keep a running tab, and then you settle up with one single payment at the end of the night. Payment channels do the exact same thing for crypto.
And here's where it becomes incredibly powerful. The Lightning Network takes this bar tab idea and connects thousands of them into one giant, interconnected web. So, as you see here, Alice can pay Bob almost instantly for basically no fee, even if they don't have a direct tab open with each other. The payment just hops through other people's channels to get there. It's brilliant.
And the process is actually pretty straightforward. First, two people lock up some funds on the main blockchain. That opens the private tab. Then they can send money back and forth between themselves off-chain an unlimited number of times instantly. And finally, whenever they're done, they close the channel, and only the final score, the final balance, gets recorded back on the main blockchain in a single cheap transaction. It's incredibly efficient.
Another massive Layer 2 innovation, and this one is huge on Ethereum, is called rollups. The analogy here is carpooling. Instead of 100 people all driving their own car onto the highway and causing a massive traffic jam, a rollup bundles hundreds of separate transactions together off-chain. Then it submits that entire bundle to the main chain as one single, neat, compressed package. It saves a ton of space and a ton of money for everybody involved.
But look, this whole quest for scalability is far from over. It's not like we found the perfect solution and we're done. This is a constantly evolving field, and the newest ideas are pushing the envelope even further.
And this right here shows one of the biggest new trends: modular blockchains. The old way of thinking was to build one giant monolithic chain that did everything by itself. The new idea is to break apart the essential jobs of a blockchain, like actually processing transactions, confirming them, and storing all the data, and assign each job to a separate, specialized layer. Each layer can be hyper-optimized for just one thing, making the whole system way more efficient and powerful.
Okay, I know that was a lot of technical stuff. So let's zoom back out. Let's talk about why any of this actually matters to you.
At the end of the day, it all comes back to that really tough problem, the blockchain trilemma. We've seen how Layer 1 solutions try to rewrite the foundation, and how Layer 2 solutions build these clever express lanes on top. But the goal is exactly the same. Cracking this scalability problem is the key. It's what will decide if blockchain tech actually becomes a foundational piece of our digital lives, or if it just stays a niche hobby for tech enthusiasts.
And that leaves us with a really fascinating question to think about. As this race for a faster blockchain continues, what does the future actually look like? Are we going to see one super chain that finally solves the trilemma and does everything for everyone? Or is the future going to be something more modular, a messy, beautiful web of dozens of specialized layers all interconnected and working together? The race is on, and honestly, the answer is going to shape our digital world for a long, long time.